The overall goal of this resonance ultrasonic spectroscopy method is to measure a complete set of material constants and their temperature dependence for a piezoelectric material using only one sample.
The impedance method defined in the piezoelectric standards of the Institute of Electrical and Electronic Engineers require 5 to 7 samples of different geometries in order to measure the complete set of material constants for piezoelectric material. The main advantage of the resonance ultrasonic spectroscopy technique is that the full tensor properties can be obtained from one sample, avoiding inconsistency caused by sample-to-sample variations. Data acquired from this method enable people to simulate the performance of electromechanical devices and quantify their performance degradation at higher temperatures using finite element method.
First, glue a rectangular parallel piped PZT4 ceramic sample to the bottom surface of a metal rod, using a very thin layer of wax by heating the rod and sample to about 60 degrees Celsius. After cooling to room temperature, tightly fit the rod into a metal cylinder with a larger outer diameter, so that the bottom surface of the cylinder and sample can be polished together to guarantee the flatness of the sample surface. Wet a plexiglass plate with tap water, and sprinkle 6 micron aluminum oxide powder onto the wet surface. Place the sample holder with the sample glued to it onto the plexiglass plate, and make a circular motion to grind the sample surface flat. Then, wash the plexiglass plate and sample holder thoroughly with tap water.